used a satellite service today? Yes. Whoa, thank you. That's good. Of course, there are two, really, in Europe at least, two broadly used satellite services. One is satellite navigation. It's built into everybody's phone, of course, built in quite a lot of vehicles. And the other is satellite broadcast, essentially a really effective means for distributing content. Actually, if you were to look overseas and look at in the US, for instance, you'll also see satellite radio, which is a mobile vehicle application, principally, and we also see satellite broadband, which I'll touch on a little bit today. We're going to talk a little bit about what the future might look like, so we're going to perhaps give you a little bit of context about why we're doing this. We're the Satellite Applications Catapult. We're one of 10 catapults in the UK, supported by Innovate UK. The Transport Systems Catapult is very much embedded in all of this work, and we're a little bit more on the periphery, but it's really one of the emerging markets for satellites, and hence that's why we're involved. But there are other catapults that you probably need to be aware of. The most recent one that's been created is the Compound Semiconductor Applications Catapult, which could well be relevant to some of the organizations here. So just give a bit about the vision. Why is 5G interesting? What are the market applications for connected vehicle, potentially for satellites as well, and some of the reasons why that might be interesting. And then Alex will take over and describe one of the projects which we've named after a fruit. So, 5G. Actually, 5G is not one technology. It's a whole smorgasbord of technologies, and it covers things, as you'll be familiar with the V2X. It covers things like technology to support augmented reality, so putting your headsets on and looking through the walls, which could be interesting for some of the applications associated with parking your vehicle before it's completely autonomous. But there's a whole range of different technologies in there. One of the things that's interesting, perhaps you came into the building today and you took your mobile phone and you found that the connectivity wasn't very good. So you switched to the Wi-Fi, and it took 2 or 3 or 4 minutes. Well, it did for me. Make sure I got the password and all the rest of it. 5G aims to solve that by making it completely seamless as you move in and out of building using these different technologies for your head-up displays and the like. But that means that it could also use other wireless technologies for communications, including satellites. And you'll be familiar with some of the investments that's taking place across the world in autonomous vehicles from Facebook, from Google, and from Amazon, for instance. Well, the same thing is happening in the satellite world, and I've clearly spoken too long on that slide. There's investment in technologies to go into space, but also high-altitude platforms, providing connectivity which complement some of the terrestrial networks. What is interesting here is the density of communications that's increasing through the use of satellites. So high-performance satellites, which we'll talk on a little bit, high-throughput satellites, but also some of the innovation in what are called, or being termed, mega constellations. And one of the latest incarnations of that is the OneWeb constellation. Again, now it's Virgin and Airbus, where instead of having maybe a few tens of satellites, Iridium being 66 satellites, this is 680 satellites in a low Earth orbit constellation. So instead of the satellites being somewhere over there, you imagine your dish on your side of the house in the UK, it points just above the horizon. Actually, they'll be right up above you. And that's one of the game changers that's taking place through lower cost access to space. It means the satellites look down on people, and you can imagine what that means from the perspective of connected car. So why all this investment? You only have to look at some of the anticipation in terms of the revenue potential from connectivity. So this is not satellites. This is Frost & Sullivan's work on connected vehicle revenues, 155 billion by 2022. Estimating something like 27% of vehicles will have some satellite connectivity in them. But it's actually quite instructive to look at the applications under those numbers and to break it down. And you can see that there's a whole range of different applications. Safety and security. We're actually working in the next generation of eCall at the moment to connect every single vehicle with a digital fabric for emergency services. Monitoring, diagnostics, remote vehicle controls for safety aspects, location-based services, communications for the passengers, so we're moving from the vehicle through the passengers in through to infotainment. And then finally you have autonomy. My perspective on this is the vehicle, for autonomous systems to work, it's actually the vehicle that makes the decision. It's about perceiving the environment. And any connectivity is only an enhancement to the perception of the vehicle. It must work in the principle of being able to make independent decisions. Not all hazards on the road networks are cooperative. But anyway, we're talking at least 100 billion of that 160 billion where connectivities are really going to be critical for delivering those services. And that's what's creating some of that drive for investment in technology. But why not just the terrestrial networks? So here's some pictures from 2013 showing across the UK, this is Ofcom data, the signal strength across different geographies. In 2016, Ofcom did some measurements again, and that measurement set was analysed by the Royal Automobile Club, and they determined that 55% of the road networks today are not covered by 4G. The worst thing is, if you've only got one SIM, it's even worse than that. You probably experienced that yourselves. So the question is, when are we going to see ubiquitous coverage from the terrestrial networks? It's actually worth looking at what the life cycle of terrestrial networks is. So on the right, you can see the blue is 2.5G, so the old GPRS. The orange is 3G, and the silver, if that's the color it is 4G. So in 2013, when this picture was taken, was the point at which the investment in 4G networks overtook the investment in 3G networks. Now, of course, that goes where the urban populations tend to be, where the high density is. And that means it takes a long time to roll it out across the network. Now, 5G is coming. Where's it going to go? Well, it'll go into the urban networks principally because that's where the major demand is. So how are we going to ensure that we have adequate performance and connectivity across the whole of the UK? Recognising that the UK is one of the fourth most densely populated countries in the world. So it's a major challenge, and that's what's driving some of this investment. Just to give a sense of the performance, satellites are a long way away, so therefore getting the signal to them takes a lot more energy, if you like. So that becomes a challenge. Some of the innovations that are taking place with low Earth orbit satellites means that the satellites are at least 10 times nearer. That's very helpful. Some of the aspects of making the satellites more capable or working in concert means that you can actually get another order of magnitude performance improvement. So these are some of the indications of the rate of change, if you like, of capability in the satellite networks. It's about 1 order of magnitude every 7 years historically, but that's accelerating. It's about a 1 order of magnitude cost per bit reduction every 5 years now, which means in 10 years' time, it'll be 2 orders of magnitude cheaper. And we've seen those kind of developments in the terrestrial networks. Satellites are good at the wide area. We'll see ubiquitous coverage of the UK, of the world, in concert with 5G. So I'm going to let Alex take over now. He's going to tell you a bit more about our project, named after not Apple, not Orange, not Raspberry Pi, but Cassis.
Thank you, Paul. So Cassis was just to basically try to exploit all the potential that would be offered from the satellite communication systems. Would be a huge increase of capacity, and I think there is opportunity now not to see the satellite technology as a competition to terrestrial, but actually to merge the two systems together. So we were looking at hybrid communication, and the objective was to deliver really to primarily serve the mobile users, where we think that is the vast majority of the growth. So there will be a huge amount of capacity. In the graph we saw before, in 10 years' time, the capacity will grow by 10 times. So capacity will be, we said, over 14 terabit per second. This huge growth in the capacity means that also we need to have a consumer that will use this capacity. Now, the current terminal for satellites are really quite bulky, heavy, quite expensive, and are not really addressable. They're not really addressable to the end users. So the vision for Cassis was to be able to make that terminal available to the mass market, make it smaller, cheaper, and really drive the growth in that sector. So the project, this one we work with all our partners listed at the bottom. These are all UK partners, and we believe there is strong opportunity for business in that area. Now, looking a little bit on the technology itself, So we're looking at both a terminal, mobile terminal for, and at the moment we're looking really vehicle, which we think that would be a huge demand for this type of connectivities. Will be based primarily for reaching high speed. I think there is an issue about frequency. High frequency is important because with more spectrum available, it is easier for satellite to deliver the huge volume of capacity. And the most of the capacity will be delivered by satellite in 10 years' time will be from KU above. So I think the idea is to, and also another major advantage is that the terminal will be much smaller. So actually we got all the element, the key blocks, to start making a compact terminal with affordable cost, which can deliver the services needed for the future connected vehicles. Besides that, some of this technology can also be, as interestingly, there are similarities of what we can do on payloads technology, and we think about Cassis could become an ecosystem in which we have terminal, dedicated constellations, which are maybe is a constellation dedicated to deliver services to the automotive industries. And yeah, and at the moment we just picture, so the key technology we are driving, this technology is of course silicon, so mass technology which can scale to large volume and reduce the cost. So we're looking really system on chip and silicon type of technology and flat panel antennas. Looking a little bit at the trend of the cost, that was one of the, I think, another challenge, I think, to enter the automotive industries. I think at the moment, this is what we see happening. So the first, in the program, we see, we aim to have initial terminal, which will be probably around, quite expensive, but still around $1,000. This will be sort of high-end user just to allow us to start the production. That will be both for GEO and LEO satellite. Now, as the time progresses and how we can basically start improving our production process, that helps to really make the same from high spec, we go to consumer market, so we reduce the cost with similar performance. And then when I think really the big increase in capacity will come from, we believe, from really LEO constellations, large, no, we talk OneWeb, but there's also, we're talking SpaceX, like 4,000 satellites. So I think the future can look like a large number of satellites in LEO. That then we can make even smaller antenna and try to even go reduce the cost to the end users. So at the moment, just look at the roadmap. We are just at the beginning, so we look at the concept definition, and we hope to start the project really next month with a prototype design and development. This will be a long phase, will be 18 months. After that, we hope to have basically, we aim to have a lab prototype, which at that point we're able to engage with really OEMs or car manufacturer, whoever want to really engage us on this journey. And what we aim really is to fit the terminal on a vehicle and start to run really field trial. And I think we go on the car track and then demonstrate how the seamless connectivity can be achieved. And then once we do that, the next step will be to test over the air with some, initially with GEO satellite, which this will be available, but later on also with LEO. And then later on, I think it will be the production and the product launch. And the last slide is, so this is not really an isolated project. I think actually we just showed on the side there on what we see really the tree of all the, how to connect the car. The terminal is just on the bottom there, and really we need to work with all the industry, with all the player in the value chain to make that happen. And I think we're really here also because we would like to engage with you. So if you have any question and you are interested in the project, which can be on the product specification, interfaces, or I think really we're here to discuss that. Also there's Christophe, which has been working on the, if you raise your hand, looking at the business development. So I think this can be a good person to talk to afterwards, or myself or Paul. And that's it for us. Thank you very much.